The global pest control industry generates over $22 billion a year. Poison pellets, snap traps, ultrasonic devices, sticky boards. Month after month, the same products, the same cycle, and for millions of homeowners, the same result. The rats come back. Here is what nobody in that industry will tell you. Somewhere in your garden right now, there are plants that rats will not go near. Not because they have been poisoned. Not because of a trap. Because of the scent. Because of chemistry. Because of a biological signal so ancient, so deeply wired into the rat nervous system, that no amount of learned behavior can override it. 7 plants. Documented by farmers in Egypt 3,000 years ago. Cultivated by medieval monasteries across Europe. Validated today by biochemists and pest researchers. And almost completely absent from any conversation happening inside the pest control aisle at your local hardware store. There is no profit in a lavender hedge. That is precisely why you have never been told about it. Before we get to the plants, you need to understand one fundamental truth about how rats operate, because it changes everything that follows. A rat does not explore a new space with its eyes. It does not listen its way around a garden. It smells. The rat's olfactory system is one of the most sophisticated in the mammal kingdom. It can detect chemical signals at concentrations so low they were invisible to scientific instruments before the 21st century. Rats smell food. They smell shelter. They smell predators. They smell whether a territory has been claimed, whether a space is safe to raise young, whether something passed through days ago. And critically, they smell danger. Certain plant compounds, specific volatile organic chemicals produced by specific species, register in the rat's nervous system not as neutral information but as a direct threat signal. The rat does not investigate. It does not adapt. It turns around and finds somewhere else to be. Here is the mistake most people make. They think pest control is about killing. It is not. The most effective pest control ever developed by human agricultural societies was about making a space that rats actively chose to avoid. That is an entirely different principle. And it is the principle behind every plant on this list. Ancient grain farmers in Egypt knew this. Medieval European monasteries cultivated specific herb gardens not just for cooking and medicine, but as a living chemical perimeter around their food stores. Farmers across China, India, and the Mediterranean independently arrived at the same knowledge across centuries, separated by thousands of miles, connected by the same observation. Certain plants make rats deeply, instinctively uncomfortable. This was not folklore. This was not superstition. This was practical survival intelligence, accumulated across generations of people who could not afford to get it wrong. Their food stores were their lives. Modern biochemistry can now explain, molecule by molecule, what those farmers observed intuitively. The volatile organic compounds, the essential oil chemistry, the neurological interference with the rat's olfactory receptors. What ancient agricultural communities understood through observation, researchers can now map at the molecular level. And yet most homeowners today reach immediately for poison, completely unaware that their grandmother's garden may have been doing the same job for free. Plant 1. Peppermint, Mentha piperita. Close your eyes and imagine the smell of peppermint. That sharp, electric, cooling wave that hits the back of your sinuses immediately. For a human, it is invigorating. For a rat, it is overwhelming, suffocating, physically distressing. The active compound responsible is menthol. Peppermint essential oil contains menthol concentrations of up to 40%. This compound interacts with the TRPM8 receptor, a cold-sensing ion channel in the nervous system. In rats, overstimulation of this receptor creates a strong aversion response. The rat's brain does not register curiosity. It registers pain. But menthol is only part of the story. Peppermint also contains menthone, menthol acetate, and a range of secondary terpene compounds. Together they create a chemical profile that the rat's nervous system classifies as dangerous. In the wild, this concentration of volatile terpenes typically signals toxic plant matter or decomposition. The rat has evolved to move away from those signals, not toward them. Ancient Romans strewed peppermint across granary floors and wove it into thatching. Medieval apothecaries recommended it for keeping vermin from herb stores. This was applied observation, not superstition. Plant it densely along the base of exterior walls, near any area where pipes or cables enter the foundation, and along garden borders. It spreads aggressively, which is exactly the point. Trim it regularly. Cutting releases a fresh burst of volatile compounds and actually increases its effectiveness. Use containers or landscape edging to manage its spread. Plant 2. Lavender, Lavandula angustifolia. Humans have used lavender in ceremony and medicine for over 2,000 years. Rats find it repulsive. The primary volatile compounds, linalool, linylyl acetate, and camphor, are individually mild to the human nose. Together, in the concentration produced by a dense lavender planting, they create a chemical environment that rodents are neurologically programmed to avoid. Linalool has been documented in pest research to produce behavioral avoidance. Animals exposed to linalool-heavy environments spend significantly less time in those zones and show elevated stress markers when forced to remain. The camphor component adds another layer. It interacts with the rat's olfactory system in a manner similar to menthol, triggering receptors associated with chemical irritation rather than scent. Medieval French farmers planted lavender along kitchen garden perimeters not primarily for beauty but because they had observed, across generations, that rats did not nest in lavender. It was considered basic agricultural knowledge. Lavender is one of the most practical plants on this list. Drought-tolerant. Thrives in poor well-drained soil. Produces its heaviest concentration of volatile compounds during long hot summers, exactly when rat populations peak. It stays where you put it and earns its place in the garden for decades. Plant 3. Marigolds, Tajit species. The most underestimated plant in any garden center. Marigolds are so common, so ordinary-seeming, that most gardeners treat them as cheerful filler. But the ancient Aztecs cultivated Tajits extensively and documented their protective properties. Colonial English gardeners planted them around vegetable plots as standard practice. African farmers have used Tajits minuta as a natural pest barrier for centuries. Every agricultural culture that grew them observed the same result. The chemistry is real and well understood. Tajit species produce thiophene, sulfur-based organic molecules with intensely sharp chemical signatures. To a rat perceiving scent at concentrations orders of magnitude more sensitive than a human, a dense marigold planting produces a sulfur-dominated chemical environment that registers as aversive at the neurological level. There is also the root chemistry. Marigold roots produce alpha-terthionyl, a thiophene compound that changes the soil in the immediate area. Rats that dig, and all rats dig, encounter this compound through skin and mucous membranes during burrowing. Not lethal. Simply deeply unpleasant. Plant them densely. A solid row along a vegetable garden fence or a ring around a raised bed creates meaningful chemical coverage. They grow fast from seed, self-seed readily in warmer climates, and happen to also deter whiteflies, aphids, and nematodes while attracting pollinators. Working constantly on multiple levels. Plant 4. Wormwood, Artemisia absinthium. This is not a gentle plant. It is chemical warfare in botanical form. The primary compound is absinthin, a sesquiterpene lactone so intensely bitter it is detectable by the human palate at 1 part in 70,000. But bitterness is only what humans experience. Rats process wormwood through their olfactory system first. The volatile oils, absinthiol, thujone, azulene, and a complex mixture of additional terpene compounds, produce a scent profile that registers as acutely aversive to rodents. Thujone has neurotoxic properties at high doses. The rat's nervous system has evolved a strong avoidance response to plants producing it. The ancient Egyptians listed wormwood in agricultural documents over 3,000 years old, specifically in the context of protecting grain stores. Roman agricultural writers Columella and Pliny recommended it for storage areas. Medieval European granaries frequently had wormwood planted along exterior walls in dense hedging. This was accumulated agricultural intelligence. Plant it along fence lines, at property boundary corners, near compost heaps, and around any structure where rat activity has been observed. Be aware it produces allelopathic compounds through its roots, suppressing nearby plant growth. Keep it away from vegetable beds. It stakes out territory chemically and defends it, which is precisely the point. Plant 5. Garlic, Allium sativum. Inside each garlic clove, two compounds are kept physically separate. The moment the clove is damaged, those compounds combine and produce allicin, that sharp, sulfurous, penetrating scent that fills a kitchen. To a human cook, it is appetite. To a rat, it is alarm. Allicin belongs to a class of organosulfur compounds that produce some of the most intense volatile signatures in the plant world. The rat's highly developed olfactory system, which relies on sulfur-based scent markers for critical environmental signals including predator detection, responds to allicin with what researchers describe as a strong, unconditioned aversive response. The rat does not need to learn that garlic is unpleasant. The response is built in. Ancient Chinese agricultural texts recommended garlic near grain storage. Egyptian records mention it in pest management contexts. As a garden deterrent, it has several advantages. It grows underground, putting the chemical payload exactly where rats dig. The leaves release volatile compounds when brushed, as any rat moving through the planting would inevitably do. And crushed garlic in water makes an effective spray for garden boundaries. Plant cloves in autumn for late spring harvest, or obtain potted plants for spring planting. Use it densely along vegetable garden edges, near compost, and around raised bed bases. It is also, of course, food. Garlic borders are doing double duty, a meaningful chemical deterrent and a harvest of one of the most versatile and health-promoting plants in human cuisine. Plant 6. Rosemary, Salvia rosmarinus. Before science gave it a systematic explanation, Mediterranean farmers gave it a practical one. Plant rosemary near the granary and the rats will find somewhere else to be. This was documented behavior across farming communities in southern France, northern Italy, coastal Spain, and the Greek islands for centuries. The chemistry is now well characterized. Rosemary produces a dense mixture of volatile terpene compounds: camphor, borneol, camphene, alpha-pinene, and most significantly 1,8-cineol, also known as eucalyptol. This compound is among the dominant volatiles in several of the world's most intensely aromatic plants and functions as a powerful natural pesticide across a wide range of pest species. In rodents, 1,8-cineol and the camphor fraction have been shown to produce strong olfactory aversion. Rosemary is also remarkably practical. It is a perennial evergreen in most temperate climates, providing chemical coverage year-round, not just during the growing season. It is drought-tolerant, thrives in poor well-drained soils, and becomes increasingly bushy and dense with age. A mature shrub can reach 1.5 meters in height and spread nearly as wide, creating a substantial physical and chemical barrier simultaneously. Plant it at the corners of raised beds, along pathways, near doorways, and flanking any areas where rat activity has been observed. In colder climates, grow it in large containers that can be brought indoors during frost. Plant 7. Udder, Sambucus. This is the one. Not because it is the most famous. In fact, most modern pest control advice does not mention it at all. But the historical record is striking and the chemistry behind it is the most sophisticated on this list. In rural communities across northern and central Europe, from England through Germany into Poland and Ukraine, the elder tree occupied a specific and deeply intentional position in the landscape. Planted at the edge of property, adjacent to root cellars and grain stores. In some regions, felling an elder without good reason was considered deeply unwise. Not for mystical reasons. Because the elder was known to do something important. It kept the rats away. The elder produces complex chemistry throughout all parts of the plant. The leaves and bark contain sambunagrin and other cyanogenic glycosides, compounds that release hydrogen cyanide when plant tissue is damaged. Not dangerous to humans at normal exposure levels, but rats processing the environment through olfactory receptors evolved to detect chemical danger signals register the cyanogenic chemistry of elderberry foliage as a serious threat. The volatile chemistry of damaged elder leaves, that acrid, unusual scent quite distinct from most garden plants, appears to trigger a hardwired avoidance response. Elder grows in almost any soil condition. It tolerates wet and dry extremes. It establishes rapidly, often reaching 3 meters within 2 to 3 years. It self-seeds prolifically. Once established, it begins to colonize along fence lines and property edges, exactly where its chemical presence is most useful. And it is a generous plant in other ways. The flowers produce the beloved elderflower fragrance. The berries, when properly prepared, yield one of the most antioxidant-rich foods in the Northern European botanical tradition. A plant that feeds you, supports your health, and quietly protects your property while requiring almost nothing in return. Plant elder at the boundaries of your property, along fence lines, near outbuildings, sheds, compost heaps, or anywhere rats have established runs. Give it space. Then leave it alone. It knows what it is doing. There is something that happens when you look closely at traditional agricultural practices. Practices that were once called folklore. Superstition. The unscientific habits of uneducated peasants. And you begin to find the chemistry underneath them. They knew. Not the way we now know, with instruments and peer-reviewed methodology and molecular diagrams. They knew through observation, through inheritance, through the accumulated practical wisdom of people who lived and died by the quality of their food stores, and who could not afford to get it wrong. Somewhere in the transition to industrial agriculture and chemical pest control, that knowledge stopped being passed forward. It sat in old texts, in monastery garden plans, in the letters of country estate managers, in the planting records of medieval farmsteads. What these 7 plants represent is not new information. It is recovered information. The science validates what the observations discovered. It does not replace them. Peppermint at the foundation. Lavender at the borders. Marigolds in dense rows around vegetable beds. Wormwood along the fence line. Garlic throughout the kitchen garden. Rosemary flanking entry points. And elder, patient and substantial, standing at the edges of the property, doing what elders have always done. You are not fighting nature when you plant these. You are joining it. If this recovered knowledge has changed the way you see your garden, subscribe now. We are uncovering the natural wisdom that the modern world buried. The next hidden secret of the natural world is coming very soon.